Good morning, everyone. Thank you for coming and joining this class. Is my voice strong enough? No problem. Okay, so today we'll discuss about continuation of Excel iteration last time. Okay, but mostly about numerical Excel, meaning that it is possible to uh, do numerical analysis in Excel. Okay. So you already did the simple counter, so I'll just skip those part. Today I will discuss more about Newton-Raphson secant method and computation of eigenvalues, eigenvector. Okay. Okay, so this is, I will just skip, you already know, Excel iteration. Okay. Okay, so what is iteration? Basically, iteration means repetition, right? So this idea to solve many mathematical problems, usually called numerical analysis. So, for example, you have a function f, and then you want to find the root x. Okay? So that the function f is equal to 0. So remember, if you have a function, okay, with an input x, and then you equate this to 0, then you want to find what x that actually make the fx equal 0, that is called root. Okay? Now, assuming the function is differentiable, meaning that you can take the derivative, okay, then you can actually create approximation, okay, by setting any initial value. For example, first time you set x equal x0, then you calculate x1 is equal to f of x0, right? And then x2 is equal f of x1. Okay? x3 is equal to f of x2, and so on. Okay, so this is the general formula. So fx subscript k, that will be equal to x subscript k plus 1. So when we will stop? You will stop when the xk is equal to almost equal to xk plus 1. Okay. So this number of x0 until xn, okay, usually will converge, okay, to a limiting value. Let's call this limiting value x star. Okay. So mathematically, we will say it like this: limit of that fxn when n is reaching infinity is the same as fx star. So then the x star is the root. Yeah. Mathematically speaking, we just call it limit n to infinity. But in reality, if you use Excel later, you just match. Okay, if xn is close enough means the difference, the absolute difference is very small, okay, then you stop the algorithm. Okay, so with that background, okay, let's do one algorithm is called Newton-Raphson. Okay, this is originally was proposed by Isaac Newton. It's always very long time, and then improved by Raphson. So Newton-Raphson is one of the most famous, okay, numerical method to find root of fx equals 0. So how to find the fx equals 0? Okay. The root is using this equation. So first you have fx itself. Okay. You divide by f accent x. What is the meaning of f accent x? That is the meaning you take the first derivative. Okay. So the function itself, the value of the function itself, you divide by the value of the first derivative. Okay. And then this is just the iteration, right? xk plus 1 equal to xk minus that number. So there's a problem here. The problem is to find the initial value. Yeah? So if the initial value near, then you can find the correct solution. If far, so probably you will be trapped in the local optima. We call this local optima. I will describe later. So let's say you want to find a simple equation like this. Find the square root of a number 7 using Newton-Raphson. So what you will do? Say, let's x is the square root that we are looking for. Set y equals 7, right? So because you want to find square root, so what is the function? Y equals 7 so that x squared equals y, isn't it? So that is equivalent to fx equal to x squared minus y. Okay, so then you take the first derivative. What is that? 2x. Right? Then you can set any arbitrary value, okay, and compute xk plus 1 equal to xk minus fx divided by fx accent. Okay, so this is first x0. Suppose you put starting with 3. Okay, so x0 is 3. So fx0, how do you calculate fx0? So you put fx0, which is x0 is 3, to this equation. Okay, so this equation, this is the fx, right? So you put x0, which is 3, so what do you get in here if you put 3? Y is 7, so then 3 square minus 7, huh? Right? And then if x is 3, 2 times 3, this one, 2 times 3 equal 6 here. That is the one that we do in here. So, okay, this is the one that we do. So then you get this answer, right? So this is called x1. Okay, so then you put this x1 here. Okay, and then you input the x1 to the fx and fx accent. Same, yeah? So you see here, this is the x1, right? And then fx is x squared minus 7, right? And then fx accent is 2 times x. So x in here is x1. So you get a new. Okay, so let's call this x2. And again, you repeat the process. Is it clear until here? Can you make it in Excel? Okay, so this is the example. Right. So you can put, what is this? This is k, okay? And you create fxk, and then you create fx, and then you create fx accent, okay? So down here. Okay, so then you will see it's almost the same anyway. So this is the answer. Okay, can you try this on your own? Oh, did I record? Oh yes, I did. Okay, so try to solve that Newton-Raphson. Have you heard about this before? Newton-Raphson? No? Okay, this is the first time. Okay, good.
No.
Anyway, when you search in Google, you can always find that also. There are a lot of entries about Newton-Raphson. Okay. It's very famous algorithm. And of course, you can use for any function. Okay. So in our case, we just make it trivia, like just to find the square root. Okay. But you can find any function, not just square root. try first, and then if you have a problem, you tell me. Yeah.
Sir, is it like this?
Can you share your screen?
So first we fill in this one, and this is normally just to the power of 2 minus 7, and sorry, and this is just B3 times 2. And then we make it from B3 minus C3 divided by D3, and then we get this, and this is we get this from B4 to the power of 2 minus 7, and this is B4 times 2, and then we just fill
Very
in.
good, very good. You see here.
This is not 0 yet, I guess, right?
Yeah.
Oh, but it's really small. Okay.
You see here, Newton-Raphson convert very fast.
Yes.
Only 3 iteration. Okay. Then 0 there. Right.
Yeah.
Well, that's why this is an amazing algorithm. Yeah? Okay. So now you have 2 parts. One part is to create this into shorter version. This is optional, okay, but just for fun. So can you make this with control and then just probably 2 or 3 rows
Okay. Yeah.
instead of very long? That is one part. Okay. Second part is, can you try any other function that you like?
Yes.
Not just square root. So, still another part. Can you change now the y into this square root? Can you change into different numbers, not just 7? And then you try whether square root of 7 is actually 2.64 something, correct or not? To test the correctness of the algorithm.
Yeah. Okay. It should be correct. 2.6. 0.645.
Square root of 7. Or you can put the y as one cell.
The y as one cell.
That one is, you input it inside the cell, right? The y.
Yes.
So if you put it the y value outside,
Oh, yeah.
always find the square root of that y. Put it into cell. Okay. Correct. And then,
Yes. And then we get this.
is that correct? So you can try y is equal 9 should be 3, right?
Mhm. Okay, sir.
Very good, very good. So, Levi, Joy, how is it? Oh, yes. 9 is always 3.
Yeah. Just checking.
So when you make that, then you can create using Excel iteration. Okay.
Sir, the x0 can be anything.
The
The x0, is it like
the X0 can be anything. So, but you need input.
Okay.
Okay. And at this point, you did not see because the function is rather simple. Just, but try to find a function that is actually complicated, not just quadratic, but say you have a up and down like this.
Yes.
Okay. Then X0 matter. I will. So if your function is just square, is just something like this, right? Quadratic. So this is clearly you have only one maximum or minimum. Right? So the meaning of that Newton-Raphson is basically finding the tangent should be 0 like this. This is the maximum or the minimum, right? 0 in here is the meaning the gradient is 0. That's why they take the gradient, right? So what happened is, if your function is something like this, okay, it's complicated, right? So then if you start x0 here, say you want to find the maximum. If you find the start in here x0, then it will go find, okay, and then it will find this as the answer. Sorry. Okay, so it will not find this one. So, but if you start x0 here, so it will find this one. The meaning of this is what we call a local optima. Yeah? So if you start here, it will probably get this one. Yeah? If you start here, what you will get? It will get this one. Can you see? So instead of finding the global, this is the global optima, right? It will find the local optima. Okay. So the algorithm always find the local optima. That means your initial value of x0 near to the global optima matter. Do you get what I mean by global optima and local optima? Okay, Joy, Livy, can you share your screen so that we can check? At least you should know, yeah, at least you should know how to compute square root of 7. Oh, good. Yes. In 3 iterations, you got it already, right? Very good. Okay, all zeros. Yes. Super. Livy, I just want to make sure that you can get. Oh, yes, very good. Okay, you get also. So, next step then. Very good. Okay, next step is what? Next step is to do iteration. So, we got this using spreadsheet, right? So, can you do it in Excel iteration, say using control? Okay. So, can you use control so that you can say, can you control it and then you can get exactly the same. Yeah. To the, I want to find your feedback. Okay, so I will do a really simple survey. So, what is your expertise in Excel right now? You're confident in Excel. 0 to 10 or 1 to 10. Just honestly to yourself, not to just to me. How confident are you in Excel that you will use again and again next time? 1 to 10. Livy,
Maybe 7.5.
7.5.
Yeah.
Oh, good. 7.5. And Joy, how confident are you?
Actually, it depends on the.
Problem.
But on overall Excel compared to other people, I might be a little bit more confident. But compared to you, no.
No,
I'm
no,
like
no, no, no,
you.
no. Don't compare to anybody. Compare to yourself.
From before, probably now, yeah, way better. I'm at 7.5.
7.5. Pancha?
Yes, I would say 7.5 is
7.5.
very good.
Confidence level is 7.5. How about Python? Oh, because you were also how confident are you using Python? 1 to 10, same. I want to compare the Python and Excel.
Maybe for me, with Python, it's 8 probably. But well, I know that there are a lot of things that we don't know yet because
Yeah,
Python
of
is
course,
so big.
nobody knows everything.
Yeah.
Right?
But
So
yeah,
your Python level
maybe
is higher than Excel. Pancha, your Python.
Maybe I think I'm more comfortable with Python because I'm used to like finding it. Yes, yeah.
How about you, Livy and Joy?
I'm way more comfortable with Excel, but in Python, I think I improved a lot because the first time I started your class, I can't even code at all.
Okay.
So yeah, I think I
Now,
improved a lot
now
in
you can
Python, but
code,
I'm still
right?
more comfortable.
So my question,
Yeah.
the rate first of your own confidence now. Say you have, then you will start to code, or you start Excel.
For Python, my confidence might be 6.5, 7.
7. Okay. How about you, Livy? No, just be honest, guys. It's okay. No, 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 no burden. Okay.
Maybe about 5.5 to
5,
6. Yeah.
5.5 or 6.
Yeah.
Okay. Next question is if there is a competition in Python, okay, programming competition in Python, are you going to? Are you willing to join and take the challenge? Not yet, or yes? No.
Depending on what is the competition, what the competition about. Like Python is so
Yes.
big. Like what do we do with Python?
Usually they will give you input and output and certain problems, and then you will create a program to get their input and then match with their output.
Oh, so we back engineer their
Something.
yeah, back engineer their program. Okay.
So there is a mathematical problem like this
Yes.
square root, something like this, right? And then they will give you 7 input, output is 2 point something, right? And then say
Yeah.
the next number is 3, no, 9, the output is 3, right? Because this is square root, right? So, but they will not tell you that this is square root.
Yeah. Okay.
Okay? So they will give you a function. For example, the function is x squared minus y. Like that. So, and then they will give you y is 7. Then you need to find the program. So they will not tell you that you need to use Newton-Raphson. You need to figure it out by yourself to code it using Newton-Raphson. So usually programming competition like this. So in Indonesia, I think the one that go into this direction is Binus, Bina Nusantara. So I used to be one of the what do you call that? Like the manager or Asian director for Asia, Manila. Okay, for a programming competition. Long time ago. But and there is an Olympic of this programming competition. Olympic, you understand? Like in the sport, you have local level in school, and then going up to city level, and then going to province level, national level, and then regional level like ASEAN, right? And then you go to world level, Olympic. So the same thing, there is also programming competition that can go up to Olympic. So say 2014, I was in that Olympiad of programming competition. So the winner was Russian. Okay. When those winner came back to Russia, he get a hero welcome and received by Putin, President Putin himself. Okay, because this is really very important for the nation, more than the sport actually, right? Because those who are excellent in programming, okay, they can actually develop the nation economy and defense, including military and so on. So this is more important than sport. This is just entertainment. Also business, right? So it's really rely on this excellent programmer. So these programmers are not made, are not just talented born. So they are trained actually. So there are certain training that we can create to let these students to join and then go up to that level. Unfortunately, or fortunately, unfortunately or fortunately, if you are not student, you cannot join the competition. The ICC only for students.
Yeah, because otherwise,
Graduated already, so bye-bye. No, you cannot join.
Yeah. Because otherwise, professional programmers
Yeah,
will
yeah.
join and they will
Right.
probably win.
Right. So only for students. So from the beginning, so fortunately for you, you are still in the beginning, so you still have 3 more years or 2 more years. Okay. The competition is every 2 years. World competition, I mean. The competition locally every time, no problem. But the world competition every 2 years.
Sir, can I show you?
Yeah, cool.
So I did a bit differently to yours because
No problem.
I used the K.
Mm-hmm.
So for example, if I put 11 and then I start,
Mm-hmm.
I have to use F9, but it will give me the final answer here when this one is 0. So
Right.
F9, then there. The final answer is 31 for 11.
Super. Okay. Share it to your friend how it works.
Oh, so wait, let me just stop it. Okay. So first of all, this is just normally, and the K is pretty much a counter that we did like last week. So if the control is empty, then it will be plus itself by 1.
This is control and either the same clock.
The same clock, yes. And for xk, we didn't normally. So if k is 0, so because k it always starts from 1, right? When I started, so I have to k minus 1 is 0. We use it will equal b33, so x0. If it's not 0, then it will count itself minus this and this. Yes, the Newton-Raphson.
Right.
And for this one, we just do it normally like this: xk to the power of 2 minus y. Oh, sorry. And this one is just even simpler, 2 times xk. And then for the final answer, so if fx is 0, then the final answer will be C3. If not, then it's going to be empty first.
This one is the last problem. Because of course for this case is okay, but for other problem, sometimes you cannot read 0.
Oh.
Okay.
Oh yeah, maybe. Oh, then
sometimes you cannot read. So then it less than 0.00001.
Yeah. Okay. Less than
0.0001. So it's just a small number. 0.001. Okay. Now how many digit you want? the accuracy. That is the one that you just
Yeah. Oh, okay. So
Okay.
for example,
there directly, right?
yes, it will get this. But then, yeah, okay, I see.
Okay. So you can set as many zero behind the decimal to make it more accurate. Okay, but at the same time, if you put it zero, that is dangerous because it will never. Sometimes, no? It
Sometimes it will never reach zero.
will
Okay.
zero. Okay, very good. So Joy and Livy, how was it? You want to share your screen?
We can only do the iteration one time.
No.
I mean,
Press
like we
F9.
gotta redo it. Yeah, we gotta redo it from the start if you want in the beginning. No.
So my point is, if you can do it using spreadsheet, right? Earlier you did, right, the spreadsheet. So you can always do that iteration, the same iteration, using the Excel iteration with control. Last time. You lack of control.
Oh, that's why. Okay. Okay, wait. I add the control first.
You lack of control. That's why. Okay. Remember the circular reference problem that we overcome using Excel iteration. Okay. You can always use that. However, that will need a certain cell called control because you need to let them start when it's starting. And you can also create a kind of sim clock similar to what Pancha did. Okay. And this is optional, but at the same time, it's give you confidence that, oh, I can create some kind of programming in Excel. How about you, Livy?
Wait, sir, not yet finished.
Okay. Pancha, you can try other function.
Yes, sir. Okay.
Any function that you like. For example, polynomial. Can you try cubic polynomial or quartic polynomial? Because quartic polynomial have 4 root, right? So can you find all the root of quartic polynomial? Finding root problem seems like, oh, just finding the root. Okay? But remember, finding root is also mean a lot of things. Okay? For example, you want to find the maximum. You want to find the minimum. That is also the same as finding the root, isn't it? Why? Because you will reach maximum if your first derivative is 0. So if you can find finding root means finding zeros, right? So if you want to find the zeros of the first derivative, okay, that means you can find the optimum value in control theory, finding root is also very important to find the pole and the zeros. Okay, so where the actual problems happen in the real systems. So Newton-Raphson is really very useful. But there is one problem in Newton-Raphson, right? What? You need to find the derivative first, manually, correct?
Yeah, manually we have
Manually.
to decide the 2x. Yeah.
So next method will overcome that problem. Okay. We call this second method. Second method. Okay. But show me first this one using Newton-Raphson first. Oh, many algorithm later in your life, not in this class, will be derived from exactly similar to Newton-Raphson. Okay. It's just an iterative iteration, simple iteration. So if I put it as the formula is xt plus 1 equal to xt, correct? And then what is this? Minus fx, right? Divided, of course, this is by f accent x, right? This is the formula, Newton-Raphson. Yes or no? So
Yes.
what we do is to generalize this, okay? So we remove this part. Okay. So, and then if we want to generalize it, I will put plus instead of minus. Okay. So, and then I will put it as delta x. So this is the general formula. Okay. How do you get the delta x? In Newton-Raphson, delta x is equal to fx divided by f accent x. But you can use a different formula to determine the delta x. Okay. So, but if you can see the form, something like this, okay, then you can always use iteration. Is it clear now? Next week we will discuss about solver. Excel also have one add-in. It's actually there called solver, and we will deal with a lot of optimization problems. So, have you taken operation research? Yes,
Yes.
this sem or last semester?
This semester.
This semester.
So, are you using solver also?
Miss Nova haven't taught us yet, but I tried it once. It gives you right away like sensitivity analysis and everything, right? In like
Okay.
one.
Okay. So what I will teach you in this class is to use the solver to solve not just LP, not just linear programming, but different type of problems. Okay. So it's just very fast how to use this problem, how to formulate, and then just run it. At least give you confidence only. The detailed mathematics behind should be taught by someone else in the real course, present research. But this was the practicality, how to get the real solution. That is the one that we try to find here. For example, traveling salary. For example, traveling salesman. How are you going to solve traveling salesman in Excel? Did you heard about traveling salesman problem? No? Okay.
Sorry, sir. Talk about what?
Traveling salesman.
Oh, we haven't.
It's called the salesman problem.
You learn about traveling salesman problem. Not yet?
Not yet.
Oh, what did you learn about LP? Is that what you are learning? Linear programming.
Yes, we learn about linear programming, like
Okay.
a simplex table,
Simple step. And then
duality.
duality. And after that, those linear programming and duality, is there any other?
Yeah, we just had our last quiz about simplex and we'll be moving on another subject. So we've learned simplex for last semester and this semester for 2 weeks, but next week we'll be changing into a different subject. So we are finished with simplex.
I see. So can you program it in Python, simplex?
Never tried it before.
Never tried it. So how do you solve it? Or just solve using hand?
Manual, yeah.
Manual?
Oh, using Excel, but
We can use Excel, but yeah, not with software.
we put
Oh,
the
okay.
iteration manually.
Oh, okay, okay. Yeah, that's good because so that you will at least know what is behind. Did you also get the shorter type table? Instead of the long table, you get the shorter table. Anyway, okay. So Hungarian method, for example, for matching assignment, not yet.
Not yet.
Okay, you want to show, Livy? I'm still waiting for you. Joy.
But I can share.
Okay. Oh, there. Okay, say 7 and then, right? And, oh, very good. Yes. You did it. Very good. So, you know how to translate from the iteration, okay, to Excel iteration. Super. Wow. Very excellent. Livy, come on. I think your level of expertise in Excel is very high already. Yes, you use control. Where's your control? Okay, put any value there in the control. Yeah, in the G2, you try to put any value. And then when you remove that value, what will happen? Press F9. Oh no, you still have a circle reference problem. You go to File, yes, Option, Formula, Enable iteration, and put maximum iteration to 1. Yes, click OK. And then try again. Oh, okay. And then when you delete and press F9, oh, what happened? So G5, Excel correct. That one is G8. Where is the G8? G8 is itself, right? G8 is itself. G9 and G10, correct. That is correct. And then next, that one is G8 square, X square minus G4. That's correct. Okay, next. 2 times, what is this? G35. Where is G35? What is C35? Should be G5, isn't it? 2 times, no. G8. This is supposed to be 2 times G8. Enter. And then, yeah, this is less than, if less than 0.00001. Instead of if G9 equals 0, you change to if G9 less than 0.00001. 1. Okay. The no you change to, it's up to you. Yeah. Correct. Yeah. Empty or whatever. Start with control again. And you delete and press F9. Oh, there you get finally the answer, right? Very good. Very good. Yeah, you get the result. Excellent. Yay. So you did it. Okay. So now let's move to the next topic, which is secant method. Okay. So I'll share my slide with you. Okay. So this is the same as Newton method, actually worse than Newton method. Okay. In terms of the number of iteration, this is longer. In Newton method, very fast, right? In 3 iteration, you get 0 already. But this is longer. Okay. However, there is benefit of secant method. What is that? You don't need to take derivative. Okay. So the way why I want to show this, because this is the way you can get the first derivative, okay, using approximation. Okay. So here it is. If you have the first derivative, okay, of xk, that is actually the same as what? Fk minus fk minus 1 divided by xk minus xk minus 1. Okay, so this is just based on 2 values. Okay? This is to approximate the first derivative. So then, secant method is basically Newton method using approximate first derivatives. Okay, so then the result is something like this in the bottom. Can you see it? Okay, if you input, okay, this f accent x with this one, okay, then you will get exactly this formula, isn't it? Because you divide, then the denominator here will go up, right? And then this one will go down. See, exactly. Okay. So this is the formula that you will use. Okay. So try to solve the same problem. The only difference is now, instead of using derivative, now without derivative. Yeah? So, okay. You see, directly you get this formula. Okay. You just put it inside. However, now you need to have two values. Yeah? Initial value, why you need two values? Because this one is fxk and then xk minus 1, isn't it? So you need to have two values. So this is like second order, okay, difference equation. So that's why you need to have two values as initial. Okay, so say you can get two values is 0 and 1. It's up to you. This is just arbitrary I put here. So then you can start to compute. Okay? Fx is 0, fx 0 is actually minus 7, fx1 is actually minus 6, right? Then you fk equal 1, then you start to compute this. Okay. X2 equal to x1 minus, you input to the formula, okay, and you get the value of 7. Okay. After that, what you will do? You will calculate the f2, fx2. Yeah? And then using fx2, what you will get? You input it into k equal 2. Okay. So you put here. Then you get the new one, the new value, and repeat again. So using this, can you make it into Excel? How are you going to put it into Excel? Table first, okay, without control. Okay. You start with table first without control. So that means you need to have y, x0, and then x1, right? So this is the final result. You just copy to somewhere. Okay. And then now you have xk and fxk. Okay. So then you can calculate. Okay. Try this. And you can check the correct result must be the same as square root of y, right? So, and then you check whether it is correct or not. Okay, so this is just to check, okay, whether the result here is the same as this one. Okay, right. So remember, in second method, it's exactly the same as Newton method, but we just replace the derivative, the first derivative, into the approximate. Okay. With that, you get second order finite difference or difference equation. And because you can get without without derivative, this is very general, isn't it? Now you can use any function, okay, without worrying, oh, I need to do a first derivative. How about if the function cannot be derived? Take the first derivative. Then you can use that. Second method. In terms of performance, is worse compared to Newton. Okay. Worse means you need more iteration. Yeah, you can try on your own. new seed. You try new seed, and then you use the same thing but using secant method instead of Newton method. Definitely Excel is easier than any programming language. Not as powerful as Python, but this is easier. Wait a minute. So you mentioned earlier simplex method you learned last semester and this semester, two semester.
Oh no, sorry. Last half semester. So before the midterms.
Okay, okay.
Yeah, my bad.
I thought I thought two semesters. What did you learn? In summary, what did you learn about the simplex method?
Uh, in simplex, we learn how to get the optimum solution and the feasible solution.
Feasible solution. Right.
Yeah.
So this is just one algorithm. Do you know the order of difference equation? I mentioned earlier that Newton method is first order, right? And secant method is second order. Do you know what I mean by that? How do you know that this is second order or first order? Okay, I will show you here. The formula. Can you see? To know the order of a difference equation, you look at the k, okay, the k value. In here, the largest k is k plus 1. Oops. The largest k in here is k plus 1. The smallest k is k. So then k plus 1 minus k, that is the order. So the order is 1. Okay. Now come back to second method. What is the largest k in here? This one, right? K plus 1. So the largest k is k plus 1. Okay. Minus with the smallest k. What is the smallest k here? K plus k minus 1, right? Correct? So then this is the largest minus the smallest. So k plus 1 minus k plus 1. So then become 2. Okay. So this is second order. Is it clear? As simple as that. Okay, the largest k, okay, minus the smallest k. That is the order. What is the meaning of that order? That is, we are using what is called difference equation, right? Difference equation means k is discrete, right? So equivalently, this is actually the same as in calculus. Okay? First order means the first derivative. Second order means the second derivative. Third order means the third derivative. That's the meaning of order. Order means the difference. Okay? So first order means the first difference, right? Second order means the second difference, meaning that you take the difference of the difference. Third order means you take the difference of the difference of the difference 3 times. Second method, who finished already?
The normal one or like the iteration one?
The iteration one, no need the control.
Oh, no need to make the one like in the Newton one, the one where we use control.
Oh, that's fine. That's fine. That's even more advanced. The one that using control is practically my own method. Okay? You cannot find in any books, right? Correct? It's only in my website. There is no other website telling like that. Even in Mr. Excel or in any other book, you cannot find. So, then meaning that if you talk to other people that they are probably expert in Excel, and then you show them, they will, oh, I don't know that. Yeah, of course, right? Because they don't know that. So over time, you can develop your own method. You know, I have developed several methods because I'm using Excel so much. So I'm using several methods in Excel that not usually people use. Okay. Not in macro, of course macro also, but just the usual Excel. So, there are also different methods to do a block computation, for example. So I will not discuss it in this class, but there are many methods that you can develop on your own, not based on what is the book say. Say, for example, can you do a genetic algorithm using Excel or something? It's possible, using Excel iteration. But we will not discuss it here, otherwise it's too deep.
Sir, can I show you mine?
Yeah, please share your screen.
Yeah.
This is
Is it like this?
the same answer, right?
Yeah, this one.
The same answer.
Then
So
this one.
the only difference is what? The only difference is now look at the number of iteration. Now instead of 3, like in Newton method, now you have 9 before it becomes 0, isn't it?
Yeah.
Huh?
Yeah.
See, k is 9, then it's almost 0. Yeah. In Newton method, you see, it's just 3 iteration, it's 0. So Newton method is actually faster. Can you see that? Only 3 iteration becomes 0, right? In second method, you need to wait until 9 iteration become 0. Yeah? In k equal 10, it's 0. So that means second method is not as good as Newton, okay, in terms of the number of iteration. In terms of generality, second method is better because you don't need to think about the manually deriving the first derivative, isn't it? So we overcome one problem, but we lose in the number of iterations. Anyway, 3 and 9 is computer is doing, so it's not really a big matter. So if I need to choose, I will choose second method. Right? So
Yeah.
try to use the same thing, not for square root, but any other function. Can you start to use second method to solve cubic or quartic polynomial, for example?
This method to solve
So I will not tell you the function. You choose on your own, okay, what function you want. Right? And find the correct answer already so that you will know. Right? Say you get search from the internet, you know already, oh, this is the correct answer. Yeah? This is the root. 1, 2, 3, 4, for example. And after that, you try to solve it using second method. And of course, if it is the root, you can check, right? So you input that x value into the fx, it's supposed to give you 0. So try on your own. Huh? That will be the assignment. Right? So today's assignment is to use second method. You choose your own. Also, meaning everyone will have their own function. You tell me what function you want. Okay. So I will set in assignment second any function. I will put polynomial function. Okay, and then find the root. Find the root of that polynomial function. Yeah. Using secant method. And then you need to test, okay, whether it is really the root. Yeah. By inputting the root into the function, yeah, to get 0. Okay, so next week, is it okay? The next week is on Monday. That will be the assignment. So that you will at least know that. If you want to challenge yourself, can you find all the root, not just one? Remember, if it is cubic equation, how many roots? 3, right? If quartic equation, that the root is 4. And oh, one more thing. I give you example here. Where should I give you example? Maybe I'll open my Excel. There. So here, I will hide the method. This one is using another method. Can I show you? This one is for quartic equation. Okay, this is the A, B, C, D. Okay, this is for quartic, okay, something like this. Okay, so I use a Duran-Kernel method for solving the quartic equation like this. Okay. So if you use a quartic equation, of course the result can be complex number, right? This is the actual result to get the 0, and this is the A, B, C, D, E, A, B, C, D. This is the equation, this is the A, B, C, D, and this is the root. And the root is complex number, not just real number. Okay, and I use iteration, the same. Very long iteration. Okay. So you can use secant method to solve a quartic equation. Remember, it's not necessarily real number, so be careful. Once you go to quadratic, cubic, and quartic, the result is not always real. It can be complex number. Aha. So Excel have complex function, so you need to use that complex function. Yeah? Okay, that's the challenge. Okay then. Anyone want to show the work for a square root? I want to leave you already did. Joy and Pancha, you want to show?
Yeah. So this is pretty much like the book. Oh, I haven't done that. Oh yeah. Wait.
This is the second.
Yeah.
Yeah. Anyway, yes. The result is
If wait.
That one,
Um,
bottom. So x20.
sorry.
No need, no need. Just result is just equal of that xk at 20.
Oh yeah, yeah, correct.
No, x
Oh wait,
p,
wait. This one, yeah.
p,
Mm,
p77. That,
yeah.
yes. Oh, same, right?
Yeah, it should be the same. Yes.
Yes. So here is to check y is equal 9, then it should be 3.
Mm,
Joy, is it okay? Oh, very good. And oh, this is the usual. Okay. And when
I have a question.
yes,
How do you recall a previous iteration? I mean, like for this one, for example, this one, we recall this one, right?
you recall the previous iteration, yeah.
I mean, yeah, I mean the Excel remembers this one because they have it in the sheet. But on like a control one, how
In
do
the
we
control one,
yeah.
so you need to have 2 cells.
But how do we
one
do
for
it? Like we showed the previous value of a cell.
The same, but you need to have 2 cells.
so one we have okay. So one have like a memory of the previous one.
Correct, correct. Otherwise, you cannot. How you
Oh,
tell?
okay.
Okay, you need to have 2 cells. Okay, good. So let's move on. The last part is this is what I promised last week. Right? This is called power method. Do you have it in your Excel? In your slide? Or did I update it? I forget. Do you have this part in your slide?
No, sir.
No? Okay, I will update now. So then, okay, I will update now. Wait, yeah. Save as. I need to go to iteration. Where is the iteration? There. I thought I already updated. Okay, so I updated the slide. To get that, you need to refresh your browser and then download again the Excel iteration. Okay, let's go to Excel iteration. So the name is called power method. So this is a numerical method to find the largest eigenvalue and the associated eigenvector. then you can ask, oh, but not the largest, the second largest we can also do. Huh? Let's do it. So what is eigenvector, eigenvalue? So if you have a matrix A, okay, square matrix, this one, yeah, then we have this equation, okay. A, if I multiply A with X, that is equal to lambda. Lambda is a scalar number, okay, number, multiplied by X. What is mean? What does it mean of this equation? Okay, what is the meaning of this equation? The meaning is this: if you have a matrix A, okay, and then you transform, A is represent transformation, right? And X here is a vector, okay? So if you transform X, this is vector X, okay, with the matrix A, it's supposed to get certain, for example, this is the A times, this is A times X, for example. Yeah? The vector is, this is the original vector X, okay? And then after you multiply by A, it will become, say for example, rotated or change direction, okay? And change the value also. But this equation means A times X equal to lambda times X. That means this is a X, right? Times the A, it will always become just lambda. This is the X. This is just lambda times X. What is the meaning? It will be exactly the same X. Okay, just multiply by a lambda. Lambda is a number. That means can be shrink, can be longer. So the direction will not change. Geometrically, that's the meaning of eigenvalue, eigenvector. Okay? The lambda here is just resizing, rescaling of the vector X. Now, that vector X, okay, that will, what is the vector X that if I multiply by A will become itself? Okay. That means that vector X represents the characteristic of A. Similarly, the lambda become the characteristic of A. That's why we eigen. Yeah? Eigen means the characteristic. Yeah? So I can represent matrix A by the eigenvalue and its eigenvector. Okay. Now, how to find the eigenvalue and eigenvector? Okay. So first, you initialize any vector. Okay. Z, example here, Z. Okay. The size must be the same as the matrix A, which is n by n. So because this is vector, so become n by 1. Yeah? You can start with random value or you can start with 1, 1, 1. It's up to you. Okay. And then you repeat. Okay. You repeat. How do you repeat? You compute the vector y. You compute the vector y, which is what? A times z. After that, you get the maximum of the y. Okay. And then you scale, okay, y with the lambda to get back the z. After that, again, you repeat. Compute the y equal a times z and so on. Okay. Until the change is very small. Okay. Say, how do you check the change? You can check from the lambda. Okay. If the change of the lambda is very small, then that is the final result. That will be the largest eigenvalue. Okay. And the associated eigenvector is z. So you can use Excel to do that. So this is just a derivation. How does it work? So you can read by yourself. Okay. And if you want to get the second largest value, of course you need to get the first one. Yeah? So lambda 1 is the largest eigenvalue. V1 is the largest eigenvector associated, the eigenvector associated with the largest eigenvalue. And then you minus A with this value, you get B. Now you use power method again to get the largest eigenvalue of B. And so on. So not so important anymore. Most of the problem that you use usually only involve the largest eigenvector and eigenvalue and the associated eigenvector. Okay, now try this algorithm of power method using Excel. Can you do? Can you do a power method? Okay, using Excel. So you can start with any matrix. So this is example. I'm using control here. This is easier to use. So I make a control here and then I create a counter as usual, right? And then this is the matrix that I inputted. So because I input this, so this become what? Yellow. And then I computed Z. Yeah. So initially I can randomize. So this is the random value of the Z. Can you see? Okay. And then initially I will equal to that value. Okay. And after that I can compute the multiplication, right? Y is equal to multiplication of A times Z, otherwise init Z initially. Okay. And then what is that? Eigenvalue is just the maximum of Y. Okay. And then the eigenvector is just the this value, the Y divided by the eigenvalue. Okay. So when you delete this, of course you get the result. Okay. Ta-da-da. See, no change anymore, right? Okay, so can you make it? So this is combined. Last time you already learned how to do a Excel matrix, right? So now instead of just number, now you use matrix computation. So this is more advanced a little bit. When you finish, you just share your screen. Huh?
Sir, how do we get the y again? The y matrix,
The y,
the y factor.
the y is a times z. Right? So y equal to
A times z,
z. Yes.
and z is just random value.
In the beginning, z is random value. Right? In the beginning, z is random value. And then after that, you get the lambda is equal to maximum of the y. After that, you can get the z. What is z? Z is y divided by lambda. Just 3 steps. After that, you can repeat again.
Oh yes, okay.
With this, actually you can do a lot of things. Huh? You can actually solve any other numerical method, yeah? Not just the one that I give this example. So you just read any books, numerical method, and then you can try on your own, okay? And it will give you certain knowledge. By trying it on your own, then you can have certain knowledge. Yeah. In this case, if you don't use control, that is more difficult, isn't it? So if you want to do a iteration down similar to early Newton Raphson, for example. So, but if you use control, that is really simple. If you visit my website, so I have several other algorithms that I solve it using Excel. For example, uh, reinforcement learning, for example, okay, which is in AI. Okay. The one that this is the algorithm behind how you solve the chess problem, for example, or Go. Yeah. that Google use for finding the solution to make the AI beat human. Okay, this is called reinforcement learning. So, of course, in the smaller version, we can also solve, for example, Tower of Hanoi and so on. This one we can use Excel in the smaller version. So again, how to solve using Excel iteration? You just use control and then check the matrix so that it will converge. There are many other things that you can also try. The more you try on your own, the more advanced you are. Similar to Kung Fu, for example, you need to practice every day. Otherwise, you will not be able to become the strongest Kung Fu master, isn't it? The same thing with you like Python, so please practice every day. Then you will have stronger. Keep challenging yourself, okay? Say you go in other courses in IPE, right? And then one of the teacher give you assignment. So you can ask, can I solve that using Python instead of manually? Then you start to create. Okay. Example, the OR a while ago. What is that called? Simplex method. Can you solve it using Python, for example? Right? So if you can, then suddenly your level of Python is getting higher. Of course, the algorithm is out there. It doesn't really matter, but you keep practicing, then you can improve yourself.
Sir, can I share my screen?
Oh, cool. I will stop sharing.
I haven't finished it yet, but what do we do after this one? Like, so I've already got this, right? So I put matrix here, and this one is
This
yeah,
is
so
the C. You can start with the initial Z. Can you create a new vector of initial Z? So let's call it init C.
oh, okay, which will be
Any random number.
oh this already random set. Wait,
Oh, you already did. Okay. So
yeah, so oh wait, oh sorry.
okay, what is the Z there?
So if the counter is 1, then it will random. If
If
not,
the
then it
count,
will multiply this, the y, divide, multiply it by 1 divided by lambda. And lambda is maximum y.
it will multiply. It will multiply what? Z equal.
No, it will multiply y with 1 divided by lambda.
Oh no.
Right.
Lambda is scalar, so you don't need to using M mode, right?
Oh yeah. Okay.
So that is a scalar. So scalar.
But how? But y is not scalar.
Y is not scalar, correct? Y is not scalar. So, but multiplication, you just multiply each
So we just do this.
each element. So let's
Oh, okay.
run that so that easier to read. You want? So it's not correct.
How to change part of an array?
No, no, not array. If you multiply by array, oh, it's a complicated problem because in one side of the if,
How do we change part of an array?
you just multiply
Sorry.
without m mul, just multiply. For example, what is this? F83 times lambda. Oh, sorry. F53. Can you share again? Can I?
Oh wait. My internet connection was quite bad. Wait. Okay. Can you see my screen now?
Not sure. Yeah. Okay. So
Can you see it?
83 in F83, right?
Sorry.
So the last part, instead of m mul, you just
Yes.
so you remove the m mul. You just multiply the H83 with lambda.
Oh, H83 with lambda.
H
Multiply.
no, divide by lambda.
Right.
Okay.
Uh,
So but the lambda
how do we change part of an array? It doesn't allow
because you put
copy
it as
because
array, so you just copy first everything and then you delete. You cannot
Oh,
part of array. So Z in this case is not array, huh? No need to make it array. Divide. Okay.
Z is not array. Okay,
Yeah, Z is not array.
so we just drag it normally.
Normally, yeah.
And this would be oh,
Better you keep names so that
yeah.
this
I
will.
don't know.
Wait. Y is an array.
Y is not an array. As
Y
well.
is an array.
Yeah, that's correct. So
Uh,
multiply.
M multiply
This is correct.
of A by Z. Yeah, but the value of Z is now 0. Not different. So let's take the control first. Put it in the value. So at this point, you're supposed to get.
Oh, okay. Wait. Okay.
So let's say you stop the control. So what you will get? If the
So if the counter is 1, then
empty, if the control is empty, then you do the other way around. But if the control is 1, oh, okay, anyway, you want to use 1.
it should be correct.
Hmm?
Okay, this is random.
This is random.
It doesn't show anything.
No, the Z is reversed. You need to put if it is if the control is empty, you divide the Y with the lambda. Otherwise, make it random.
Oh, okay.
Right? If the control is empty, equal. If the control equal empty, then you divide. Okay, and then otherwise, use a random number. Okay. Okay, set the control to any value first. Okay, this is the random number. Okay, now if you delete the control, oh, Oh, there.
Oh, okay.
Yeah.
The lambda keep changing.
Yeah, the lambda keep changing. The lambda is the largest of y, is it?
Yeah,
Yes.
but it's never the same, is it?
It never the same. So your iteration is not converts. it
Oh wait, it settles on 16 though.
is it?
Yeah,
It's sectal at 16. Okay. So it's supposed to be 16.11,
11, I guess.
right?
Yeah.
Yes. The iteration is a little bit long, unlike Newton method. Okay.
Okay. So what do we do after this one, sir?
Yeah. So then you get that. You can try if you want to try whether it is correct or not. You can try matrix A times X, which is in this case the X is what, the Z, right?
Z.
So matrix A times Z, M A times Z, okay. M mole of that of A and
Z.
Z.
And
Okay, just put it up.
isn't it just the same as Y?
Supposed to be Y times 16. Supposed to be Z times 16. Remember definition of eigenvalue, eigenvector.
Oh, so this one should be Z times 16.
Later, you need to have two columns. One is this.
Oh yeah, okay, wait.
You just enter first that one, and then
F2,
yeah, because it's
right.
right. And then the second one is lambda times Z. Okay, so that one is just scalar. No need.
Oh yeah.
Lambda is scalar. So the lambda you need to put okay.
Yes.
Is it correct? Oh,
Oh yeah, it's the same.
yeah, it's correct. So yes, you get the correct answer.
Okay. Yes. So
Okay.
the lambda will settle. Okay.
Yes. So you
So,
now you can
yeah.
change the matrix for any number. Okay, the one that you know, for example.
Oh, the one that I know, I don't remember anything. Oh,
You can
wait.
check in the internet or using any other.
Yeah.
So then, say for example, if matrix is identity matrix 100010001, what is the lambda and the eigenvalue?
Oh yeah.
So put that as yellow so that you will know that this is the input.
Yeah. Okay. Wait.
Yes. Okay, and you run it. Okay.
1.
One.
The identity matrix is 1.
Yes. Yes.
Yeah, the lambda of identity
The lambda
matrix.
is
It's always 1 right there.
always one, right? And now you can start to try, for example, a stochastic matrix. For example, stochastic matrix is a probability matrix that the sum of row must be 1. So what is the lambda? So using this,
The
you
sum of row must be 1. Oh, okay.
so for example 0.5 there, right? And then 0.5 and then 0. 0.5 and then 0.5, 0. Okay, and then any 1/3, for example, 1/3, 1/3. Okay,
Right.
5, right? And then 0 and so 0.7. It's up to you.
4.
4.
Yeah.
Then try and run. There. Not yet. Until
It
the
should be 1 as well. Yeah.
Yeah, it should be 1 also, right?
Yeah, it's settling on 1.
Settling on 1.
Yeah. Okay. There you go.
Okay, there you go. Okay, so using this, you can experiment, using linear algebra, right? So I hope this will help you in your course of linear algebra.
Mm.
Okay, good. Thank you for today. So I already posted several slides on solver in solver optimization. Okay. I think I have 6 slides there. I can add more if you want. Okay, so can you start to read those slides? I think I can add one more probably there. So probably the next 2 weeks we will discuss about solver. I think this is very important. Oh, I have already. I have 8. Okay, so this is 2 weeks is enough. So I hope you can finish fast by reading all of these 8 slides, okay, in the next 2 weeks so that we can progress very fast. Okay. Thank you for today. And
Okay. Thank you, sir. See you next week.
Thank you, sir.
yes.